This is the final video for lesson 4.5, solving linear systems, and I want to take a look at how we would use technology to solve these problems. So what we have here are two equations. So this is the last one about Vic's videos and Dixie's DVDs. So we have our two equations. One of the equations is C equals, I'll just write them down. So for Vic's, it's C equals 1.5n plus 10. And for Dixie's, it's C equals 2n plus 4. All right, so we're going to take those two equations and we're going to use what's called Desmos. So you can get to Desmos in one of two ways. You can either go to desmos.com and that will get you, then you want to go to, I think it's the calculator or something like that. You can also go and download this app and you'll use it again in your high school career. So you might want to, it might be worth your while to actually download the app, and the app is just called Desmos. It's a really good app to have for math classes. Okay, so we have these two equations, C equals 1.5n plus 10 and C equals 2n plus 4. So 2n plus 4. Okay, so now what I'm going to do is I'm going to go into Desmos. So I'm going to take Desmos. Whoops. I'm going to bring it over here. Okay, so now Desmos can work in variables other than x and y, but it really does prefer x and y. So instead of putting C in, I'm going to put y in because remember, cost is your dependent and your dependent is your y variable. So I'm just going to just do this. I think that'll work. So remember, it's the x's are on the left and the y's are on the right. It kind of goes in alphabetical order. X is on the left and y's on the right. So when you open Desmos, you basically get yourself a graph, and this isn't going to look exactly like yours. Actually, you know what? I'm just going to throw that over there. Okay, so this is kind of what you get. Sometimes your lines are on the side and your graph is on the other side. Other times, sometimes when you're doing this on your phone or something, you might get the lines are at the bottom and the graph is at the top. It doesn't matter where they are. So the first equation that we had was y equals 1.5, C equals 1.5n plus 10. So I'm going to type it in as y equals 1.5 x plus 10. Okay, and so there, now when you're moving Desmos around, if you just put one finger on the graph, you can move the graph around. I know you can't see my finger, but I just have one finger on the graph right now. If you put two fingers on the graph anywhere other than on the axes, so you're, again, I can't write on here. It won't let me write. So no, it's not going to let me write. So if you put your two fingers, like you can zoom in and out, you can do it this way, zooming in and out. You can also, if you put your fingers on the axes, so if I put my one finger, say at negative 15 on the vertical axis and at positive 25 on the vertical axis, I can change just my vertical axis. But your fingers, both fingers have to be sitting on the axis. As soon as I move one finger off the axis, then it zooms the whole thing in and out. But if both fingers are on the vertical axis, I can change just the vertical axis. And same with the horizontal. If both my fingers are on just the horizontal axis, I can change just the scale on just the horizontal axis. And you need to be able to manipulate your graph because sometimes your graph is way off. Like sometimes you've got to zoom, like you got to really zoom to be able to see what you want to see. Now we don't have to do that in this case. We actually want it to be where we were before. And the other thing too is, like, take a look here. I'm going to zoom. Whoops. Now I've lost my whole, there it is. Okay. So sometimes you just got to look around. If you get all totally lost, if you click on the little house, the house will take you back to a normal graph, just a normal scale. Okay, so that's one of our lines. The other line is y equals, or c equals 2n plus 4. So I'm going to type in y equals 2x plus 4. And there's the other graph. I love Desmos because you have two different colors. You can play up here with a little wrench. You can change it so that it brightens or thickens up the lines. Again, you can manipulate your graph all you want so that you can see it. Now, the cool thing now is, I'm just going to go back to normal mode. The cool thing now is we can see that these two lines are crossing, and if I just touch on one of the two lines, so I just touched on the blue line, and that highlighted the blue line, but it didn't just highlight the blue line, it also showed me the point where the two intersect. So this makes graphing really easy and really accurate. I use this all the time. I use it in my calculus class. I use it in my grade 10 class. I use it all the time when I need to figure out something. It does some other cool little things, which I'm going to talk about in the next video. I can click on the red graph, and again, it does the same thing. It highlights that point where they intersect, and then if you just touch that point, it will tell you what the coordinates of it are. So this method of solving a linear system by graphing is way better than graphing it by hand. Using the technology, you can easily find the point of intersection between two lines, as long as you've got the equations. If you don't have the equations, so if I go back and we take a look at, let's go back to example number 2. So the example about the job offers. We didn't have the equations, we had a table of values, but we can make the equation. So if I take a look at, say, equation, or the first one, the starting value is 200. I've already figured out what the crock is. So the pay is $200 plus the crock times the hours worked, and let's say that's H. And then for job offer number 2, the starting value is 0. So pay starts off at 0. It's going up $200 every 8 hours. So the crock on that one is 200 over 8, which I think is $25 per hour. $25 per hour. So for job offer number 2, there is no base pay. It's just an hourly rate. Job offer number 1 gives you $200 as a base pay, and then they're going to pay you $15 per hour after that. So the cool thing about job offer 1, you work 1 hour, they're going to pay you $215. That's pretty cool. Anyway, so for job offer number 2, there is no starting salary. Well, there is. It's 0. And they're just paying you $25 per hour. So now, if I go back into Desmos and I type in those two equations, but again, I use X's and Y's instead of P and H's. I just have to write them down because I'll forget them if I don't. Okay, so now I'm going to go back into Desmos. I'm going to clear out these two equations. Now I'm going to type in the first one as y equals 200 plus 15x. And then you can hit enter, or you can hit the next line, and you type in y equals 25x. Now notice when you look at the graph, I can't see all of them. I can't see everything. That's because the green one starts at 200. So if it's starting at 2, I got to change this axis. So I'm going to bring, remember, one finger down at the bottom of the axis and another finger dragging. Okay, so now I'm getting these two graphs in line. I click on either one of them, And sorry about that. I click on either one of them, and there's my intersection point at 20 and 500. So for 20 hours of work, both companies are going to pay $500. Now let's just take a look at the last one, or the very first one again. Remember, we already calculated what these two equations are. We figured them out right here. So 3,600, A is 3,600 minus 100N, and A equals 100N. So I'm going to go back into Desmos. I'm going to clear these two off. And again, I'm going to do Y equals instead of A equals. So Y equals 3,600 minus 100X. And then click on the second line, and that's just 100x. So you can see I can't see both lines fully. Again, manipulate your axes. There we go. Intersection is at 18 and 1800. So after 18 weeks, both bank accounts, remember this is all about Rex and Roxanne, after 18 weeks, both bank accounts will have $1,800 in them. So as long as you can figure out what the equation is for the relationship, whether it's given to you as a graph, as a table of values, as some words, you can figure out the equation. We've worked on that for several lessons now. Then you can just type those equations. Whoops, I forgot to see. It's pretty cool how Desmos knows that I really wanted the Y equals in there, and I didn't even have to type it. I thought I did, but see, it's not changing anything. Okay, so you can definitely use Desmos to check your answers, to check what you've drawn. I am 100% okay with that. In fact, I would love it if you did that. All right, that's it for today. We'll talk to you soon.